We're going to look at solving a system of inequalities, but before we get going too far in that, I want you to notice the implications of two of these words. Inequalities means we're not going to have equations, which is equal signs. We're going to have greater than or less than or equal to type of signs. And a system means we're going to have more than one of these. So to kind of review that, earlier in this unit, we would graph one inequality. This is not a system of inequalities, but we would take this and just pretend it's y equals mx plus b. Go ahead and graph that line because that is less than and doesn't have an equal sign underneath. It's a dotted line. And then we would shade. Either you would use a shortcut and say that's a less than sign, so I'm going to shade below, or you would pick a test point, plug it into here, find out if it's true or false, and always shade to a true test point and shade away from a false test point. But that is one inequality. That's not a system. And then to continue the review, earlier in this unit, we did solving a system of equations. Equations means you have an equal sign. System means you have more than one. And this is the type of problem where we said, hey, you've got three choices. You can graph them and find the intersection, use substitution or elimination. But in the end, you're going to get an x equals and a y equals some number for both of those, that when you plug those numbers in, it makes this equation true and it makes this equation true. But enough with the review. We're going to do systems of inequalities, which means we're going to have two inequalities. And as I go through this, follow along with these purple steps. You may want to pause the video and write those down because that's the procedure you're going to use for every one of these inequalities problems. Here's our system of inequalities, and you see that there's two of them, and they have not equal signs, but inequality signs. So step one is I want to graph these two. Well, this one's ready to graph because it's in some version of y equals mx plus b. This one's not ready to graph, so I could either graph by intercepts or I could solve for y. I'm going to pause the video and solve for y. Okay, so you see my work. I took this inequality, rearranged it to solve for y, and now I wrote my new system. The first inequality stayed the same. The second inequality, all I've done is I've rewritten that so that it's easier to graph. If I didn't want to do that, I could graph this via intercepts. Well, I'm still on the first step, which is graph them. So now what I'm going to do is I'm going to take this first inequality and graph it. Well, it's in y equals mx plus b form. So my y-intercept is 2. Let's see, I'll do this one in purple. My y-intercept is 2. My slope is -1/2. So -1, +2, -1, +2. Or I could go +1, -2. Either way, I'm going to get dots that follow the same line. And since this is a less than sign, it doesn't have an equal sign, I'm going to create a dotted graph. All right, so I've graphed the top one. Now I'm going to graph the bottom one. The bottom inequality is now graphed right there. So I've taken care of my first step, which is graph them. The next step says shade them lightly. So you'll see why you want to shade them lightly. So now I have two inequalities, and remember from the review, we're used to shading. When we have just one inequality, we graph it and we can shade it either using the shortcut of shading above or below based on that sign or using a test point. So when I do this shading, I have to kind of ignore one while I work on the other. So in this case, I'm going to ignore the bottom inequality and just think about this top one. This is the one in purple, dashed line. And it says y is less than negative 1/2x plus 2. That means I want to shade beneath or below this purple dotted line. So a lot of times what I'll do for myself is draw a little arrow below. So that's indicating that I would shade everything below there. And if you feel like shading everything below there, that's fine. I'll do that a little bit later. Now you look at the other one, which in this case is this, I guess, teal colored one, and it's a y greater than or equal to that graph, which means I would shade everything above, or I would do some test points and figure it out as well. But I'm going to draw little arrows for myself. Okay, so, and I'm going to now do a little shading just to show you what that might look like. This shading is going to be really light, so I'm not sure how well that'll come across on the video. But if I'm shading below the purple line, I think of this, and I'm just totally ignoring the teal colored line. Now if I'm shading above the teal colored line, it's looking like this. And I got that, I can also envision that by thinking about those arrows, but if you want to take a pencil and lightly do that, it's probably a good idea. So I've done step 2, which is shade them lightly. Now it says, shade the intersection of the shaded regions. Well, that is our solution region, and if I look closely, the only region where I shaded twice, or where the two shaded regions intersected, was this area right in here. It's always going to be a compartment of your graph. So I'm going to shade that darker so that it stands out. This is our solution region. This is the intersection of the two shaded regions. And if it's our solution region, that means any ordered pair from within that region will make this inequality true. Both parts of the inequality would be true. Let's test that out. Here's how we test that out. I'm taking a point from within the solution region, -3, 1. If this is really the solution region, this point will make this inequality true and this inequality true. So I take the x equals -3 and the y equals 1, and I'll plug it into this first inequality. I replace the y with a 1, the x with a -3. So it's that same inequality, just with the numbers replaced. And now as I work through this, I end up with a 1 is less than 3.5. Is 1 less than 3.5? Heck yeah, it's true. But for it to be truly a solution, it has to work in both of those. So now I take this one, y and x get replaced with a 1 and a -3. So is 1 greater than or equal to -3 minus 1? Or in other words, is 1 greater than or equal to -4? Heck yeah, that's true too. So my point in the solution region satisfied both of those inequalities. Let's see what would happen if we would take a point outside of the solution region. Let's try this point over here. This is the point x equals 3, y equals 0. So I've chosen a point from outside of the solution region, and when I plug the x and the y, remember x is 3, y is 0, when I plug it into the first inequality, I end up with a true statement. But that doesn't make this a solution yet, because remember, it has to make both of those inequalities true. So when I take the x equals 3, y equals 0, and I plug it into the second one, now it's a different story. I end up with a 0 is greater than or equal to 2, which is definitely false. That's not a true statement. And because I didn't say true to both, this is not a solution, which is obvious because it's not in the solution region. The big deal on these systems of inequalities is following this simple procedure, which depends greatly on your ability to graph lines. If you follow that procedure, you'll end up with a pretty picture with a shaded compartment that is your solution region.